Okay, let's talk about the ambiguous case. Ambiguous case is when we use the sine law and there are two possible triangles. So as you can see here, there's a simple diagram to illustrate what's happening. So we have two sides, A and B, and if A is equal to H, we only have one right angle triangle. When A is greater than H, well, it's greater than H and is less than B, then there are two possible triangles, as you can see in the diagram. And lastly, if it's greater than B, there's obviously just one possible triangle. But we're focusing on the case of when it's less than B but greater than H kind of case. However, the important thing to note is that if there's an accurate diagram, if there's a diagram of the triangle on the exam, then that triangle is not ambiguous. You don't have to waste time determining if it's ambiguous or not. If there's a diagram of the triangle, it's not ambiguous because you know how the triangle is going to look like. There's only one possible triangle. That triangle is how it's going to look like. So let's try an ambiguous case triangle problem. So in triangle ABC, A is equal to square root of 2 and B is equal to square root of 3. And the angle A is equal to 45 degrees. Find the possible values of angle B. And again, when you solve these kind of problems, it actually comes pretty natural. This will be sine 45 degrees divided by square root of 2 is equal to sine B over square root of 3. And once you solve this, this would be, sine 45 is 1 over square root of 2. So if you divide that by square root of 2, that would be 1/2. It's equal to sine B over square root of 3. Which means sine B is equal to square root of 3 over 2. And if you actually think about the quadrants and how they lay out sine, that would be, there are two possible outcomes here. One of them would be 120 degrees. So this is square root of 3 and square root of 2. And the other one would be 60 degrees. This is square root of 3. This is square root of 2. So there are two possible outcomes in the quadrants. Meaning that B is equal to 60 or 120.